Hi friends, are you ready to learn the concepts of density, relative density and flotation in a simple and practical way? Let's try an interesting experiment. For the experiment, first I will pour honey in the glass. My mom won't be happy with me stealing so much honey from the kitchen. Next, I will pour some water. And now I'm going to pour kerosene. As you can see, we have three layers here. Kerosene is above water and honey is below water. Now let's drop in some objects. First, I will drop a steel nail. See, it sinks all the way down. Next, let's put in a grape. You can see that the grape floats on honey but sinks in water. Now let's put in a bottle cap. The bottle cap sinks in kerosene but it's floating in water. And finally, let's put in this plastic ball. The ball floats on kerosene. How is this happening? How do the liquids magically arrange themselves? Why are objects floating in some liquids and sinking in others? Let's rewind the experiment and first look at the liquids. As you can see, water is floating on honey and kerosene is floating on water. These three liquids are not mixing with each other and they form separate layers. Now, how can we predict if a liquid will float on another liquid? It's based on the density of the liquid. Density of kerosene is less than water. That's why kerosene floats on water. And the density of honey is greater than water. That's why water floats on honey. So whether a liquid floats on another liquid is based on the density of the two liquids. What is density? Density measures the heaviness or lightness of a material. Density is a measure of how tightly packed the particles or molecules of a material are. Density is defined as mass per unit volume. So the formula of density is going to be density equal to mass divided by volume. Density we denote with the symbol rho. Mass with m and volume with v. So our formula becomes rho equal to m divided by v. Now what is the unit of density? You can easily work it out by using the formula. The SI unit of mass is kilogram and the SI unit of volume is meter cube. Density is mass divided by volume. So the SI unit of density is going to be kg per meter cube. The CGS unit of density is also commonly used. And what will be the CGS unit? It's going to be gram per centimeter cube because mass is measured in gram and volume in centimeter cube. So the CGS unit of density is gram per centimeter cube. The density of water in CGS unit is a very simple value. Do you know what it is? It is 1 gram per centimeter cube. The density of water is 1 gram per centimeter cube. This means every centimeter cube of water weighs 1 gram. You can visualize this by taking a tiny cube of size 1 centimeter by 1 centimeter by 1 centimeter. And if you fill it with water, the mass of the water in that is going to be 1 gram. So every centimeter cube of water weighs 1 gram. Now, do you know what is the conversion between the CGS and the SI unit of density? That is the conversion between gram per centimeter cube and kg per meter cube. The conversion is 1 gram per centimeter cube is equal to 1000 kg per meter cube. So if you take a big cube of water, which is of size 1 meter by 1 meter by 1 meter, and you fill it with water, then the mass of the water in that cube is going to be 1000 kg, right? So you can easily remember this relation. 1 gram per centimeter cube equals 1000 kg per meter cube because in CGS unit the size of the cube is very small. It's 1 centimeter cube. But in SI unit it's a cube of 1 meter cube, right? So this is the important conversion, that density of water is 1 gram per centimeter cube in CGS units and in SI units it is 1000 kg per meter cube. The density of kerosene is about 0.8 gram per centimeter cube. Density of kerosene is less than the density of water which is 1 gram per centimeter cube. This is why kerosene floats on water. And the density of honey is about 1.4 gram per centimeter cube. This is why water floats on honey. So the liquid with lower density will float on the liquid of higher density. There is also the concept of relative density. Relative density of a substance is the density of the substance in reference with another substance. That is why it is called relative density. Usually the reference substance is taken as water. So the relative density of a substance is the density of the substance divided by the density of water. Now what do you think is the unit of relative density? That's right, it does not have any units since both the units of density will cancel each other. Now what do you think will be the relative density of kerosene and honey? Can you work it out? Let's start with the relative density of kerosene. The density of kerosene was about 0.8 gram per centimeter cube. So let's use our relative density formula. It's going to be density of kerosene divided by the density of water. Now the density of water you should substitute as 1 gram per centimeter cube because we are using CGS units, right? So either use CGS units for both densities or SI units. So here our relative density of kerosene is going to be 0.8 gram per centimeter cube divided by 1 gram per centimeter cube. And gram per centimeter cube gets cancelled. So finally the relative density of kerosene is simply going to be 0.8. Now what about honey? Honey had a density of about 1.4 gram per centimeter cube. Again, you can find the relative density by using the formula. So it's going to be density of honey divided by density of water. Once again, the units will cancel each other and we get the relative density of honey as 1.4. So note that relative density does not have any units because the units cancel each other. Relative density is also known as specific gravity. So you can remember that term as well. Just like we saw that a liquid floats on another liquid based on its density, the same concept of flotation can be applied to solid objects floating or sinking in liquids. An object will float in a liquid if the density of the object is less than the liquid, and the object will sink in the liquid if the density of the object is greater than the liquid. Now based on this concept, can you tell me what will be the density of the steel nail? It is definitely more than the density of all the liquids here because it sinks in all the liquids. And so its density is greater than the density of honey. The density of honey is about 1.4 gram per centimeter cube. And the density of steel is much higher. It's about 8 gram per centimeter cube. This is why the steel nail sinks in honey. Now what about the density of the grape? Clearly the density of this grape is greater than water. That's why it sinks in water. But the density of the grape is less than the honey because it's floating on honey. So the density of the grape is greater than 1 gram per centimeter cube and less than 1.4 gram per centimeter cube, the density of honey. Now how about the density of the bottle cap? It sinks in kerosene but floats on water. So the density of the bottle cap is greater than 0.8 gram per centimeter cube but less than 1 gram per centimeter cube. And this orange plastic ball, it clearly is lighter than kerosene. That's why it floats on kerosene. So the density of the plastic ball is definitely less than 0.8 gram per centimeter cube. So we can apply this concept of flotation, that if the density of a solid is greater than the liquid, it will sink in the liquid. And if the density of the solid is less than the liquid, it's going to float in the liquid. So this is the important concept of flotation based on density. If I drop an ice cube in the glass, where will the ice settle? As you can see, the ice sinks in kerosene since density of ice is greater than kerosene. But ice floats in water since density of ice is less than the density of water. Now let me ask you an interesting question. We know that the density of steel is much greater than the density of water and the density of honey. That's why the steel nail sinks in water and honey. Then how does a massive steel ship float in water? According to the condition of flotation, the density of the ship should be less than water. But the ship is made of steel and steel's density is greater than water. Then how is the ship floating in water? Do let me know your answers by putting it in the comments below, and I promise to reply to your answers. So think about this interesting question on density and put the answers in the comments below.